Before that, let me just show you a quick video. And I apologize, it's me in the video, but it'll give you a very quick summary of what this is all about.
What is decentralized AI and how does it compare?
Is the audio coming through?
AI? We all know what's happening in the AI world. Large tech companies or organizations are centralizing data, compute, and even governance. And this is unsustainable because in many applications, whether it's health, finance, surveillance, mining, the data is owned by individuals or individual organizations who don't want to share it. So the idea behind decentralized AI is ability to work across distrusted, disconnected, and disinterested entities and take their partial information to create a global AI. To do that, we need to solve four major problems. And the four pillars are: how do we create privacy-preserving machine learning? The second is how do we incentivize these distrusted, disinterested entities to actually participate and share data and knowledge? The third is how do we verify that they are good actors? And finally, we need some kind of a dashboard, some kind of a UX. The good news about decentralized AI is that we don't have to start from scratch. Web3 is peer-to-peer and it's distributed across many entities. A lot of the building blocks of Web3 can be actually used as part of decentralized AI. So what can decentralized AI do? The community AI, the collective AI, is going to create the democratization of AI. If you can decentralize intelligence, it starts behaving more like a human society. Each of us, individuals, are intelligent on our own, but we are decentralized. And I think decentralized AI will behave in a similar way. Then we're going to actually stimulate more innovation. Let's take a concrete example of pandemic health. In the beginning, even a chest x-ray would not reveal whether this is a COVID pneumonia or a traditional pneumonia because doctors here in the US just didn't know. So let's imagine we run some kind of a future decentralized AI platform where all these clinics, all these hospitals in all these countries participate in this ecosystem. The Chinese and the Koreans and Italians who unfortunately suffered through this pandemic much earlier, if they had shared all the intelligence, we could have solved the pandemic problem of COVID pneumonia very quickly. The notion of decentralized AI and AI agents are closely tied together, because the notion is that every individual, every organization will have their own personalized agents that are working on our behalf, some kind of a digital twin that also has the agency to negotiate on our behalf, bring the right information at the right time, and also do predictions and simulations. If you want to create a new healthcare AI, the pharma company, the local pharmacy, individual patients, hospitals, the insurance player, they're all going to be individual agents, and they'll be talking through a Web3-like platform and very quickly figuring out how to create a global intelligence by looking at all the small partial data that are observing in the ecosystem. So what are some risks in decentralized AI? Any algorithmic orchestration also creates its own risks. And we have seen that play out in the Web3 world, where when the stack of Web3 technologies was getting weaker and weaker, the taller the stack is. And many exchanges crashed and many currencies crashed because they didn't think through all the possible ways individuals could be adversarial. Of course, all these different AIs can talk to each other and they can also coordinate. As humans, it takes a lot of time for us to convince multiple humans simultaneously, but the risk with decentralized AI is that this could happen very quickly. They could be misinformed, they could be misguided, they could be taken over, and so on. And so it's very important to deploy decentralized AI in low-stakes scenario in the beginning, and then over time start deploying them into health, finance, energy, and so on. So how do we get to decentralized AI? I think the big challenge for decentralized AI is to start stimulating research in thinking about how do we create localized AIs that's good for one or two particular tasks, and collectively they become better. I think in areas like healthcare and fintech, people understand this because health data and financial data is the most private data. So there's a lot of momentum behind solving decentralized AI in those two sectors. But in reality, decentralized AI is applicable in many areas. I really hope there are multiple centers in many universities, many organizations, many countries that focus on decentralized AI and really take decentralized AI as a new technology, not just a growth in the AI trajectory, but just think of this as an adjacent parallel thread that will really go solve the real world problems. And I think there is a possibility that decentralized AI over time will become much bigger than what we call AI today.
Fantastic, fantastic. So with those comments, let me just share with you some thoughts on this networked AI agents in decentralized architecture. I'm Ramesh Raskar, professor at MIT, And as you mentioned, NANDA is a very large collective of multiple universities, multiple companies, and startups coordinating this open source effort. And the very first question I like to ask is, in the era of computing, which one was a bigger deal? The invention of PC or the network of those PCs, which is internet? And the same thing is today. What's going to be bigger, AI or the network of those AIs? Nevertheless, we are in the mainframe world of AI, where we are using DOS-like commands to interacting with mainframe computers that are sitting somewhere else. From there, very slowly, we're switching to the intranet of AI and AI agents, where the agents stay within a trusted known topology. So if you're using Salesforce agents or Microsoft Copilot agents, they stay within trusted known topology. Then we'll move to the internet of the AI agents, where these agents have to navigate outside their wall boundaries in a trustless environment. And finally, the internet was about connecting computers, and now we have to connect people. So internet to the web was a big shift. Tim Berners-Lee, right here at MIT, brought four main technologies that help us create kind of a human-centric internet, with HTTP, HTML, URL, and a browser. And that's a similar vision for NANDA, which is we have to create this network AI agents with decentralized architecture, where you'll have these agents that communicate, navigate, socialize, but also more importantly, learn, earn, and transact on our behalf, sometimes autonomously, sometimes with human in the loop. And so Nanda is really building a quilt in a post-AI world, and there are many aspects to it. There is a foundation layer, which we will talk about today, which is about registries and authentication. Then there is trust, there is reputation, there is KYA, know your agent. Then there's communication, and very soon after this, we're going to hear from the A2A team at Google and MCP. So there's fantastic momentum on the communication aspect, but we need to do much more. We have to also solve, the coordination and orchestration of that. Then there's transaction and marketplaces, applications, and so on. So what are we doing at MIT and the Nanda team so far? We think that there's 7 key problems that need to be solved to really create the quilt in a post-AI world. The first one is, this ability to create agents that can take data and automatically come up with intelligence. That's the world of AutoML, which is something my team invented about 10 years ago. Second is how we're going to deal with data across agents while maintaining privacy-preserved machine learning. So techniques like federated learning from Google or the technique like split learning from MIT are really suited for some of these approaches, but they have to be upgraded for agentic web. The third is verifiable AI, and today's session is going to be mainly focused on this aspect. Then there is transactions, right? And the transactions are not just about, the agents are not just going to transact in data or money, but they also have to transact in intelligence. So how can one agent buy from another agent 1 kilogram of intelligence? What does it mean to buy 1 kilogram of intelligence? What is 1 kilogram, and how do you decide what its pricing is? So all the research we do and others are working on in the field of knowledge pricing becomes very critical. Then there are population models where the agents, just when I buy an umbrella from Amazon to Cambridge, it shows up from Vietnam all the way to my doorstep for $10. How's that possible? It's possible because there's aggregation in the ecosystem, and the amortized cost to me are down to $10. So similarly, we need agents that figure out if they're working on something similar and aggregate the resources so that the services can be provided at a very low cost. So there are many aspects of this quilt that need to be solved. I won't go into the detail today, but go to nanda.mit.edu to see a lot of the ongoing work in this space. And with the quilt, the Nanda fabric is what we see here in the blue color. That kind of unlike the World Wide Web in the 90s, where everything had to be built from scratch, I think the benefit today is that in each of these boxes, there are many companies, many startups, many researchers already working in this, but we need a quilt that puts together this connective tissue, connecting all those efforts. So that's why we call this a quilt in a post-AI world. So we'll hear more about A2A and MCP and how they work together. But what we are doing at MIT is actually creating end-to-end demonstrations that hopefully lead to reliable protocols that use these mechanisms and adds other components that are necessary. So as I said earlier, communication from A2 and MCP is great, but we have to solve many other aspects like search and discovery and authentication and trace. A scientist from our group, Ayush Chopra, will be showing you a live demonstration in a few minutes. So, our lab is very fortunate to be part of this journey for last 10 plus years in AutoML, privacy-preserved machine learning, knowledge markets, knowledge pricing, decentralized agent ecosystem. But we have so much more to do. And that's why we have created a coalition about 15 different universities. And this is an important slide I want to share with you. On one hand, on the horizontal axis, we're making progress on intelligence. I would call it kind of the raw intelligence, spending billions of dollars, centralizing data, centralizing compute, centralizing talent. And we're making very good progress on the raw intelligence of the horizontal axis. But the vertical axis is about network intelligence. There is a chance that we can create these micro AIs, milli AIs that all talk to each other. And if there are billions of such micro AIs, simple agents, by exploring the world together, in a reinforcement learning sense, they can learn from each other and then eventually reach to the top right, which is a highly decentralized AI with very smart trillions of AI agents. And so the effort behind Nanda is really focused on this goal of what does the world look like when you have trillions of agents. The work that's going on in the community today is mainly focused on enterprise AI agents. But as we start thinking about consumerization of these AI agents, including small and medium businesses that cannot be hosted on large platforms, I think we'll see a world that's very similar to how we shifted from the mainframe era of the 80s to the PC era of the 90s. And that's the one that unleashed the World Wide Web. So very excited how this will go. So this is a very broad community for Nanda. We have registries, we have clients, we have servers, we have schemas, we have know your agent protocols, and we're working with other industry partners such as MCP, A2A, with IBM, with Cisco, and so on, about how all this quilt will actually come together. So we encourage you to go to nanda.mit.edu and look at our GitHub and start building. Many startups, many companies have already launched their demos on this platform. As I mentioned, we also have about 15 universities that are part of our root nodes that will provide the registry services for this. So we're delighted to share this with you and see how we can take this forward. Thank you. All right.